Referring to the autosomal dominant pedigree chart below, who is heterozygous for the allele? So heterozygous means we have one dominant allele, one big one, and one recessive allele, one little one. So the way to figure this out is to look at offspring or look at parents to determine if an individual is heterozygous or homozygous, if they have the trait or they're affected by the trait, because this is a dominant pattern of inheritance with the allele. So if you have that big dominant allele, whether you're heterozygous or homozygous, means you have the trait. So individual 1, is this one heterozygous or homozygous? We know that individual 1's affected by it because it's a shaded square, but let's look at the children. If we have the mating set up here between individuals 1 and 2 in generation 1, we see that one of the offspring, the daughter 4 in generation 2, is not affected by this allele. And individual 2 is homozygous recessive, so that's little a. Therefore, individual 1 has to be a heterozygote because individual 4 is also homozygous recessive. Therefore, individual 4 has received one recessive allele from mom, one recessive from dad. So individual 1 is a heterozygous individual. That also means individuals 2 and 3 are heterozygous as well in generation 2, because both of them had to receive a little a allele from their mother, but they definitely have the dominant allele because they are affected by this. So in generation 2, individuals 2 and 3 are affected. Individual 1 in generation 3 is also heterozygous because individual 2 in generation 2 married a male who is unaffected, so that person's homozygous recessive, which means one of these alleles had to go to individual 1 in generation 3, so that individual is also heterozygous. And now, for individual 5, who is affected by the trait but married into the family, this individual has to be heterozygous as well, because their children, or their daughter actually, individual number 2 in generation 3, has that little allele from her father and a little a allele from her mother as well. So therefore, every shaded individual on this pedigree is heterozygous. If they have the trait, they are heterozygous, so that is choice A. Individual 1 in generation 1, and then individuals 2, 3, and 5 in generation 2, and individual 1 in generation 3.